computed tomography. The video introduces a non-contact measuring method using X-rays to scan the part for possible evaluating the dimensions, porosity, and internal defects of the part. On the left side of the industrial computed tomograph is the source of X-rays. In the middle is the rotary table on which the scanned part is clamped, and on the right side is the 2D detector recording the electrical signals. The scanned part, the tube with outer diameter of 14 mm, was fixed in polystyrene block, which, due to its low density compared to metal, is almost invisible to X-rays. Due to this feature, polystyrene is ideal for easy and fast clamping of parts when scanning on a computed tomograph. It is important to notice the warning, so the lid door must be closed during the scanning so that X-rays don't pass outside. For the interest, the covering of the machine weighs 4 tons. From this moment, the scanning continues in the software, where the process can be observed in live mode. The rotation of the rotary table can be seen in the software. The operator sets the X-ray voltage and current values, the time required to acquire a single image, the resolution of the detector, and the position of the scanned part relative to X-ray source. The software works on the basis of shades of gray, and on the histogram is possible to observe the peak defining the value of the gray of the part's environment and the peak of the value of the gray of the metal part. The scanned part must be fully visible in the scan window, and then the process of scanning can be started, in which it is necessary to set the number of projections, the filter used. In this case, a 3 mm thick copper filter was used, and activate the correction of the acquired images, which will form the 3D model. The scanning starts. During scanning, the part rotates continuously around the axis of the rotary table until it is rotated 360 degrees. It is now possible to see the position settings that were visible in the software. The process of the scanning can be followed during the entire process on the computer monitor, to which the image is transmitted, which is recorded by the X-ray lamp. In this case, the entire scanning process took 30 minutes, but depending on the accuracy of the scan, this process can take up to 2 hours. The VG Studio Max software version 3.0 is used to evaluate the data obtained from the computed tomograph when it is first necessary to import the VGL format. The import time depends on the size of the acquired scan, the values of which can be up to tens of gigabytes. After loading, the preview of the scanned part in digital form is available, and it is possible to evaluate the part either in individual sections or in the 3D window. Before evaluating the geometric tolerances and dimensions, it is necessary to set the interface in the histogram between the vertex representing the environment and the metal part. This definition can be made by selecting an example of environmental density and selecting an example of the density of the part itself. Therefore, the edges of the scanned part are calculated by software. From the surface recognition process, the 3D model of the part with its internal structure is obtained. The part can be rotated, zoomed, and recognizes elements such as plane, cylinder, and other geometrical definable elements from which it is possible to create sections, projections, and connections into one element. Subsequently, all these created characteristics can be used to create a coordinate system of the part according to the drawing documentation. Each element will fix one of the axes. After creating the coordinate system, it is possible to evaluate the part based on its definition in the drawing in individual sections. For clarity, it is possible to adjust the background color and also magnify the view several times. Section planes can be moved according to the needs of a specific section. It is possible to evaluate the distances as well as the radius or diameter of the circle, whether inner or outer. For a clearer representation of the measured values, it is possible to use labels with specific evaluated data. The software also allows the evaluation of geometric tolerances such as flatness, roundness, and geometrical product specifications. My question is that what are the differences between a computed tomograph for medicine and for industry?
Probably the intensity of the gamma rays.
X-rays, yes. The intensity of the X-rays, exactly, the Röntgen rays, very good. It's a big difference. Some other differences or difference. The difference between the tomograph for the medicine and for the industry is in the kinematical structure of the computed tomograph. Do you know this machine? What was presented in the video? This video is on the hall of the Center of Excellence of 5-axis machining. I think that everybody was in the hall and seen this computed tomograph. Is it true?
Yes, we've been there already.
Okay. So thank you very much for your answers.